review to see a preview for you and so on and so on. And yes, to start. First, that's normal. Always we have the position in the modern Hptlc, then the overview of the functions. Block diagram is my favorite always because I have to explain what we are doing and what is the devices, how it works from the schematics, and then we have also we have to test in the service modes. Test mode is mainly only to test the motors and the pneumatic parts. And service mode is mainly for to adjust mode. When you have to adjust from stepping motors if something is not in line. Especially for the application of the lift, or something on the table, or something is on the rack is not in the right line. Then we have also documents, certifications, and in the end we have also troubleshootings together, and then we make it hands-on. That's what we want to do, and yeah. In the end, question, that's always the question. But I think during the presentation there are always questions. Give a sign, and then we can always answer of this question. We are here now on the indicator part. What you see? That is to switch it on. Then it's a full automatic application device. That means you prepare your application, your samples in the rack, then you program it on the software, which is controlled via vision cats or WinCats, what you prefer. Then we have here the rack with 66 standard vials, and we have also a possibility for spray and for output application. Spray means that we have, in normal case, spraying a band, small line. We have spraying a small line, but we have also the possibility to spray a dot. But this dot spraying is not as good as this as the contact application with the contact needle. That's a different. Later we want to compare it. What is better? Because then, if you have a spray application with a dot, yes, it looks like you have a small flag on the side. That means you have a small part which looks like a flag on the plate. And give you not a very nice view of the application. Then we have no limits at application position and form with WinCats free mode. This always we have free mode for vision cats, because free mode we are also using to producing our UV test plate, for example, for the visualizer. In vision cats we don't use free mode. It's a special program. It's like you can use it like a plotter, where you can spray left, right, and in the normal standard Hptlc you have only one line beyond one other. We are spraying, and here we have the free mode possibilities.
But free mode was also good for big volume. If you can make 3 or 4 bands, then make foxing, then start development. This was much better.
But you can also make it here. You can make
some
lines, or you can also spray areas. This is also possible.
Yes.
It's also possible. I don't know if it's mentioned here. We have a heating nozzle. Okay, that we have mentioned. It's option. And what we can do is not only spray in line. We can also spray in area.
Oh yes,
this is possible. With the ATS4 is also possible.
Yeah, it's okay.
And you can make you can a big area. You can also spray. But what I think is very helpful for the free mode, if you have a horizontal chamber, and from both sides you want to start application. In normal case, you have to applicate one plate, and you have to turn the plate to the other side.
Yes.
In free mode you can spray one side and then the other side in one way, and then you can directly applicate.
Yeah, you are right.
That's much better. And here is the procedure. You see, that's why I would mention here. See the bottleneck of the septum. When you see the puncher, but this puncher is not touching the liquid only the needle, because the needle is also, because the puncture goes back, and then the needle inside will also clean from the rinsing syringe and outside from the septum puncture. The next one is the septum puncture goes back, see, and after that the needle goes also back and starts the application with beginning of the waste plate, for spraying, and then starts to applicate on the real spraying part. Then you see what I mentioned. We have here the part for the after the final application is the waste position. It goes in the waste bottle. Oh, sorry. And then after that we have the blue one. Here is blue. It's the rinsing part. Here we have a pressure of about 100 millibar. And in the side we have a vacuum about minus 50 millibar for vacuum. And I think it's not very, let me look if we can, it's not possible to pick up. I don't know if you have good eyes and see everything. You are young, no problem. The block diagram, I think it's very helpful also because in the block diagram you see the back side. I'll show you first is this one. We have here the nitrogen inlet with about 5 to 6 bar. Then we have here the pressure guard, which is detecting. There's a window from 3.5 to 3 and 6 to 4.8 bar, because we have two different. This is the old model with 3.5 to 3.8 bar, and the new has 4.8 bar. If you have about this is the borderline, then it gives a signal for the pressure connect to gas. Will be appear on the display. Then we have a low pressure. Then we have here a reducing part, P1 called. Then we have from 5 to 6 bar, or from 6 bar we have here a reducing to 3.5 for the old model. For the newer one, 4.5 bar. And then it's splitting. One goes to the septum puncture. And one we have also here reducing, because here we have a special screw, because the movement of the septum puncture is also with the ventil here controlled with the septum puncture valve, and we can change here the speed by changing also the diameter of this tube. That we have high pressure. High pressure means that we have a higher speed for the septum puncture and for the cylinder. And then the other goes to 0.8 bar. Then you see it on the manometer. And the other one goes to the spray valve. The spray. And one goes directly here to the bubble here, to the rinsing bubble. And we're also splitting from 0, and then we have here reducing again from about, what do we have here? 0.1 bar goes directly to the rinsing bottle, and the other spray valve is controlling the spray application here directly to this ring, which goes directly to the nozzle. By the way, the nozzle looks like inside, because we are producing this nozzle ourselves. It looks like this way. It looks like this. Then we have another one. They're connected. So there are here 2 holes. And there's a O-ring. And here this is the needle. And we have here, if it's connected, and we have the special holder with the blue or black tube. And tube. That means here this is blowing inside and produces a special, here's the drop of the part and here's the spray plate. It produces yes, special spray application because for spraying, like paintbrush. So if you tighten this too much or you have a special tool and you bend it too much, it will be blocked inside everything. Always hand tighten.
You can somehow dot it.
This kind of one.
Can dot it.
Yeah.
The bend will be like dotted the sample.
Yeah.
It will not be bent.
That's very important that you don't forget this because I don't know if there's we have the head, yes, and the one or the other. You can unscrew it and you can look inside and can turn around, please. This is very important because if you tighten this too much, you will tighten it with a special tool and you expand it, and you have no chance to use it. Because then it's destroyed and it's very expensive. And there's also a black O-ring on the top. If you lost this one, you have problems. You can order this. It's how we can order this. Yes, it's possible. I don't know if this O-ring is also written on this block diagram, but it's possible to only this O-ring you can order if you lost this. Yeah, not the complete unit. Good. Then you see what we have here: the pressure for the septum puncher and the pressure for the spray application. Only for the spray application, because for the contact application we don't need pressure.
Then just the external.
Yeah, yeah. Then on one goes to the rinsing bottle. You see the red one. This is the pressure. Then we have the blue one. This is the vacuum pump. The vacuum pump have a regulator for the outlet pressure. Which we have here a sucking vacuum for the waste bottle, because from the syringe to the waste bottle and from the waste position here and the outlet we have together with a valve together in the waste bottle a vacuum about from minus 100 millibar about here on this side. And for this why we have the vacuum regulator. When you remember, it's this part, I don't know, it's not, it's here on this side we had it, so no. Is it lying here maybe? This reducing part?
Ah, boom, boom.
No.